In this class, we will take up once again the numericals of the lesson Current Electricity, 12th class physics. We are still doing the topic combination of resistances in series and parallel. The question I am taking up is the exercise question. It is 3.3 question in the NCERT book. Let us read the question and understand it. 3 resistors 1 ohm, 2 ohm and 3 ohm are combined in series. What is the total resistance of the combination? So we have 3 resistors which are combined in series and we have to check what is the total effective resistance of this whole combination. Second part of the question, if the combination is connected to a battery of 12 volts having EMF 12 volts and negligible internal resistance, obtain the potential difference across each resistor. Okay, so this combination is now connected across a battery and we have to calculate the potential difference across each resistor. So if you remember, I have told you that the potential differences across each resistor is different in case of series. So it's something like this. See, this is one resistor. Okay, these are the carbon resistors. So if you have 3 resistors which are connected in series like this. Okay, this is the question. 3 resistors are connected in series. What is the total effective resistance of the combination? So it is something like this. This is one resistor, another resistor, and of course the values are different, but just a symbolic diagram of the given question. 3 resistors are combined in series. This is one resistor, this is second, and this is third. And you're asked what is the total resistance of the combination. Now, if the combination is connected to a battery of 12 volts, of course this is 9 volts battery. It is just a symbol. It is to show it is connected to a battery. Suppose it is 12 volts and it is not having any internal resistance, then what is the potential difference across each of the resistor? So this is the question. Now actually this is the case and we draw it, we symbolize it, this whole thing, to solve the questions. Now let us symbolize this. So let us draw the circuit diagram of this. We have a resistance which is having value 1 ohm as per the question. Another resistance connected to it, just like I have shown, it is of 2 ohms, and we have the third resistance connected to it having the value of 3 ohms. They are combined in series. And remember, what is series? When one end of the resistor is connected to the, like this. When we have a resistance, one end of the resistance is connected to one end of the second resistance and the other 2 ends are not connected. Okay, this is the series and we are showing it like this. One end of this resistor is connected to one end of this resistor. So they are in series. Now the series resistance, they are connected to a battery having the value 12 volts. So we will symbolize this by the symbol of battery of 12 volts, and this is our complete circuit of the given question. Now whenever we start solving it, what we do first is we label the battery. Okay, we write positive and negative here. This is 12 volts of course, and when we write positive and negative, this means from positive the current will come out. It is coming out and then this will move further. It will move to 1 ohm resistance, to the 2 ohm resistance, 3 ohm, and then back to the negative terminal of the battery. Okay, now in this process the potential difference does not remain same. The potential difference across each of the resistor is different. Each of the resistor, because of its value of resistance, encounters different potential difference, and we are going to use Ohm's law to understand the value of this potential difference. And remember, what is Ohm's law? It tells you V is equal to the product of current into resistance. Okay, so to find out current, we will be calculating it this way. right? Okay, so these are the two equations which we generally use. Now let us calculate the question. Three resistances are combined in series. What is the total effective resistance? So you remember the formula for resistance of series? Let me once again write that. Whenever two resistances are in series, supposing this is R1, this is R2, then equivalent resistance is given by R1 plus R2. This formula we have derived earlier. We are going to use it now. So R equivalent is equal to, here in this case we have three resistances. So R1 plus R2 plus R3. This is our R1, this value is R2, and this value is R3. Okay, so it's a simple question. 1 ohm plus 2 ohms plus 3 ohms, that makes it 6 ohms. Okay, so the equivalent resistance of the circuit is 6 ohms. This is the first part of the question. Now understand the second part. If the combination is connected to a battery of 12 volts and is having negligible resistance as shown in the diagram also, obtain the potential difference across each resistor. So potential difference across 1 ohm is, we are taking as V1, across V2, across the 2 ohm resistance, it is taken as V3 across 3 ohm resistance. So let us calculate. Potential difference across 1 ohm resistor. Okay, potential difference across 1 ohm resistor is equal to, how much is it? It is equal to, V is equal to I into R. So what is the current, value of current which is flowing through it? Oh yeah, we have to find the total current which is flowing through it. I will just calculate it into resistance which is R1, that is 1 ohm. Okay, so current which is flowing through it, that is the total current. Total current is the current which is coming out of the battery, and the battery sees this whole resistance as one equivalent resistance. The battery does not sees it as three different resistance, it sees it at just one resistance. So the current in the circuit is given by Ohm's law again, V upon R, and here the value is 12 and the equivalent resistance here is 6. So it is 2 amperes. So 2 ampere current is flowing through the circuit and it is passing through each one of these resistances, and due to resistance value, each resistance has its own potential difference. Okay, now calculate that potential difference. It is I into R1. So I is 2 ohms. So we have this value 2 multiplied by R1 is 1. So that makes it 2 volts. So 2 volts is the value of potential across the first resistor. Now the second one, potential difference across 2 ohm resistor. This is again given as I into R2 because the current is same. See, the charge which is entering this is leaving this. So the value of current is same in all the series connections. So the value of current we already know, 2, and the R2 is 2. So that means 4 volts is the potential difference across 2 ohm resistor. And finally, the potential difference, in short we can write it PD across 3 ohm resistor. This is given as I into R3. So it is 2 into, let me write it here only, 3, that is 6 volts. So each one has different value. This is V1, this is V2, and this is V3, which we have mentioned in the circuit diagram. Okay, so in this way we always solve the series and the parallel combination.